have it on. For people who are absent today, what we're doing is we're going to do a little bit of notes, and then we're going to take a math workshop test. It's 10 problems. You can use your notebook. You must show work on number 9 and number 10. I'm going to help you with it. It's going to be like a checkpoint. I would like for you to make 100. It's just how long will Arturo persevere. Okay, so that's the good news is there should be 2 easy 60% grades. The bad news is Seth can't believe we're still doing math, but I'm telling him I'm trying to give him nice gimme grades. Oh my gosh, all he has to do is give me a little effort, and I'll give him some nice gimme grades. Give me a little grief. Okay, I asked you to write down these 3 problems from that semester exam study guide. We're going to do them today. Now, what Arturo was supposed to do on number 25 is he was supposed to say there's not supposed to be negative exponents. So he was supposed to put 25 to the 3 halves in the denominator. He was supposed to say, oh, I know the square root of 25 is 5. So it's really 1 over 5 to the third, which is really 1 over 125. But that's not what Arturo actually did because it's the end of the year and he's forgotten a lot of this. What did Arturo do instead? Let me answer myself so we can help your life go a little faster. Arturo forgot this. He doesn't know what this is. That's why he's writing this down. Arturo is going to put it in his calculator exactly as he sees it. 0.08 is the same thing as 1 divided by 125. So Arturo is going to use his calculator to figure out the answer. He's smart. He can type things in. The only thing is he's got to make sure he puts the negative 3 halves in a fraction. So I did 25, and then I did raised to the, and then parentheses, negative 3 divided by 2. But you could also, if you really liked that fraction button, it was alpha y equals, so 25, and then raised to is that little caret symbol. 25, and then the little caret symbol. And then if you wanted to do alpha y equals negative 3 over 2, you could. Oh, that's a good question. We can do that. You're a genius. And I've already given your group 10 points, or else I'd give you more points. If you press math frac, it turns it into a fraction. Thank you for reminding me my calculator could do that. I had forgotten them. It was amazing. God bless whoever invented the calculator. Okay, so on number 11, literally going to do the same thing. Negative 32 raised to the 3 divided by 5. 32. Miss Compton can't type today. Negative 32. Raised to the 3/5. And this is how I typed it in, and that is the wrong answer. Why is that wrong? It didn't have to be a decimal. Why is my answer wrong? It's because it's negative. I've got to put the negative 32 raised to the 3/5. I need to put it exactly like it was on my paper. Oh, it actually is negative for once. But and the reason that is because it's odd exponents. But you and I both know sometimes your calculator tells you it's negative when it's really supposed to be positive, and it's really not the calculator's fault. It's really your fault for not putting it the way you saw it on your paper. So make sure you're putting it the way you see things on your paper. So number 11 is negative 8. And then number 12, sad day, we're going to have to use our brain for part of it. I can type in the 125, so I can do 125 raised to the 2/3.
Don't you have to break down the answer?
We are going to. Let's one step at a time, but yes, good idea. 125 raised to the 2/3, I get 25. So I know the number is 25, but I've also got to deal with the x to the 6 raised to the 2/3. When you're raising powers, what do you do with the exponents? You don't add. Yes, you multiply. So it's supposed to be 6 times 2/3. Alpha y equals 2/3. I get 4, so x to the 4th. So my answer is 25 x to the 4th. I did 6 times 2/3 because I was raising power, so I multiplied my exponents. I got 4, so it's 25 x to the 4. Okay, so we took a test yesterday on right triangle trig, which Alex, you didn't get to do, and I'll let you do that today too. So we took a test yesterday on right triangle trig, which is great, but you learned right triangle trig in geometry. We got to somehow take what we did, what we just tested on, and apply it to what you need next year in your next math class. So today, I know it seems random, but we're going to talk about how to do angle measure. Because once we can do angle measure, we can use a unit circle, and I swear to goodness, the unit circle is like the key to tree in life. So I know you learned this in geometry, but let's talk about it again. You know what an angle looks like. You used to have to like measure it with a protractor or something. There's initial side and terminal side. Until I saw those vocab terms again, I'd honestly put them out of my brain, so they're not important to remember. The important thing to remember is that, you know how you read a clock going clockwise? That's why it's called clockwise. When we read angles, we actually go counterclockwise. So, for instance, I start here and I go this way. When I'm reading an angle, I go counterclockwise. I think that's weird, but that's the way we've always done it in math, so you've got to roll with it. Okay, and then how many degrees are in a circle? Yeah, 360. So if I take, and the same with a clock, so if I take it and I go all the way around, so I start right here and I go all the way around with my angle and come back to my initial point. I've made a circle. I've gone 360 degrees. So the max you can do is 360, which is not true. 360 is if you've gone the complete clock all the way around. You could keep going. You know, the clock never stops. So for instance, number 4 says 450. They just went all the way around and then some. Okay, so if we're thinking things through, if this is 0 and this is also 360, because I start here and then if I finish here it's 360, then every little, you're like, well, what's that dash, what's that dash, what's that dash? You know, on a regular clock it's like 3, 6, 9, 12. Well, in math class it's 360 divided by 4, 90. So this one's 90. 90 times 2 is 180. 90 times 3 is 270. So it's 90, 180, 270, 360. Yes, you're supposed to just know that this is where 90 degrees is. You're supposed to just know this is where 270 is. You're supposed to just know these 4. If you just know these 4, normally you can figure things out. I hadn't been trig in a year, but knowing those 4, I can figure things out. So it says to sketch the angle and it's 100 degrees. Well, that's going to be a little bit past 90. No big deal. And then, of course, this initial side's over here, but it seems kind of dumb because the initial side's always there for us. Okay, I'm going to go to number 3. So it says 225. Well, I know the initial side starts here. If this is 0 and this is 90, and this is 180, and this is 270, then 225 is somewhere between 180 and 270. So it's somewhere in here. I'm not even being that exact today. I'm just in a hurry. So we're just like, yeah, somewhere down there. And then, so for instance, 210, well, 210 would be even closer to the 180 mark. No big deal. But of course, this is math class, so sometimes you have to do a little more thinking than just that. So they might ask you to go backwards, so to go clockwise, or they might go too many times around. So let's look at 4 and 7. On 7, they go 450, which means they went all the way around 360 degrees, and then they went some more. So 450 minus 360 is 90. So they went all the way around, and you can draw this with an arrow if you want to. I did that ugly. So my initial side was here, and I ended up going all the way around, and then I went even some more. So my terminal side is actually going to be here. So all you actually have to have drawn on your paper, ignore my ugly arrows showing things. All you actually have to have on your paper is this and the 90. You don't have to have the ugly arrows showing it, circling and circling. That's just me explaining things. It's like, again, it's like a clock. You know, it keeps going and keeps going. So 540 minus 360 is, I don't know. $180. So seriously, they started at 0, they went all the way around, and then they went 180 more. So it's seriously, this is the angle, which I get you're like, Ms. Compton, you just drew a flat line. How is that an angle? It still is. It had opened, and now it's flat again. So I get it's stupid. I'm with you. I know you probably intuitively understood this to begin with. We just need to understand this in order to do the unit circle, which is what you need to know, because knowing just right triangle trig is not going to help you with your next math class that day. Okay, so negative 45 degrees means instead of going up 45 degrees,
We go down.
you go down. You go the opposite way. So I'm telling you, we normally read counterclockwise. So negatives, you actually get to go clockwise. So negative 45 degrees would be down here. I would actually get to go this way 45 degrees. Well, I mean, if we're thinking it through that way, this would be negative 90, negative 180, negative 270, negative 360. Or if you don't like this negative thinking at all, you could always do 360 minus 45 is something bigger than 270. Kenzie, 360 minus 45. What is it, 315? And if I had told you 315, you knew this was 270, you knew this was 360, you probably would have drawn it in here anyway. So if you can't stand the negative, just do 360 minus your negative. They're the same thing. They're the same position. Okay, so negative 75, instead of going from here up to my positive 90 degrees, I'm going to go down almost 90 degrees and end up down here. So here to here would be negative 75 degrees. I don't know if I explained that well. It seems kind of dumb. I'm with you. A 10-point easy grade is on the back. Yay, amaze. So they tell you, like, hey, I go from here to here, and they show you that they've gone negative, so you know you better go down negative 135. And then you just follow it around, you'll end on the end. So you have a maze, and then you also have a math workshop